Screen. Can you see the screen?
Yeah.
Can you see the screen?
Yeah.
Okay. All right. So these are some questions that we can practice. You can tell me the answers for each of these. And I can do one thing with this. I can shift it to okay. Yes. So you can tell me the answers and I can write them down. Can you hear me?
Yeah. I'm figuring it
Okay.
out.
Okay.
For the first one, is the answer 3.
So it's asking you n of
1 then.
yeah, one. That's correct.
For the second one is a half.
Yes.
The probability that a member of set B. Is it 1 out of 4?
How?
I just guessed it.
Okay. See, it says that the element is chosen at random from set A. Set A means it's either 3 or 7.
Also half.
Yeah, so half is going to be the answer.
How am I
No,
supposed to shade this?
sorry.
How should I say shade this?
You have to tell me that. How would you? So I'll shade it for you. You tell me what region it is going to be.
Okay. So it says A is
Yeah.
that. and then B. So we shade A and B. So A
And then
union B. We shade the whole thing.
wait. So see, there's a complement.
Yeah. Oh, okay. So we shade the part that we want. Yeah. Okay. So we shade everything that is outside of A union B.
Exactly. So the universal set without A and B is going to be shaded.
Yeah.
Okay, good. Okay. Now let's do this.
And then I'm gonna shade A intersection B. Oh, that's easy. Okay. So A is this, and not B. Yeah. So not B is. It's gonna be um. Oh my. Only A, but like not the intersection part.
Exactly. So only this part. Okay. Do you think you can easily do part A? Question number 2, part A?
Yeah, that was easy. Yeah.
Okay. Part A, second like thing as well. Write down the set P union.
That's easy. Yeah.
Okay.
I just want to like learn how to shade it and like tell the thing that like can you go a little bit of yeah, this, right? If they ask me like what does this shaded Venn diagram tell us? That's the thing. Like, how am I supposed to know this? How am I supposed to tell them that this is A intersection B not?
Okay. So that let's cover that today then. Let me see. There were other shading as well. Let's complete the shading. Okay, this one.
Oh, okay, that sounds easy as well. So A and C and then intersection. Okay, I can shade this. Oh, is the answer A and C, but like not the anything that intersects like A and C is not there, like B, like you know what I mean?
Yeah, so you mean this part, right?
Yeah, that one. That.
Yeah, that's correct. Good job. Okay, these are like simple questions. Let me see, I think.
Like this, yeah. Uh, like the intersection part, yeah, that's
Yeah,
shaded. Now, if they tell me that what is this? Like is it like A intersection B not union something like that? Like how am I supposed
yeah.
to tell them that?
Okay, can you give it a try?
30 cent. Okay, yeah, I can, but that's easy. XS5. Yeah, the second one is hard. Yeah, that's what I'm trying to tell. Use set notation to describe the shaded region. Yeah, that's the thing. How do I do that?
Yeah, I want you to give it a try from what you've learned from shading the diagram. Give it a try, and then we can do it together.
Is it C intersection M?
Okay, you're saying C intersection M, that is correct. But what about B?
Intersection B.
Okay, so you have told this. Okay.
No, yeah, that, yeah. And I think
Mm,
that's correct.
So C intersection M means this part,
Yeah.
and then its intersection with B is this part. So that's absolutely correct. What you've told me is correct. Good job with this. So you just need to, I mean, what was your thought process when you did this? How did you think about it?
No, but I don't think that's correct, yeah?
It's correct.
How? Because if I do C intersection M, that's that, yeah, and then intersection B, so it's only gonna be 7.
No. Wait, sorry. Okay. So you said C intersection M, which is this part. Yes, wait. So, no, yeah, this is incorrect.
Yeah.
Yeah, this is not going to be intersection, but it's not going to be union either, because if it's
Yeah,
union,
it's gonna be
then
something
all,
else.
yes. So let me see what it is going to be. Let me think. Mhm. Okay, so in this case, um, I'm looking at the mark scheme right now, and it just says that you're just going to write C intersection M, which is, I mean, I don't agree with this. Let me come back to this. Okay, let's do the other questions first, and I'll come back to this, because when it's a three thing, we have three sets. You have to put all of these three in. I don't know why the mark scheme says this. Let me come back to this. Okay.
Oh.
What about this one?
3. So there's gonna be 1.
Yeah. See, okay. Mm,
Okay. So all of A and then the universal set.
yes. So B complement and all of it.
Yeah, all of A. Yeah.
It's B complement.
Yeah, so if we do B complement,
B complement union A. So it's going to be this.
there's gonna be the intersection part as well.
You're saying it's going to be this.
Yeah.
A union B complement. If I do B complement,
Yeah, but there is union, right? So even A counts.
yeah, it does. You're right. So all of this is going to be shaded. It's union. Just give me a minute. I'll be. You can. So you can just. Okay. What about this one?
Oh, F intersection F, yeah, and then union A, so that and that. So 1, 2, 3, 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Yes. Okay. And part B.
Okay, not F. intersection C S, right?
Hello. Just give me 2 minutes. I need to solve this issue. Just 2 minutes, okay? Okay, I'm sorry about this. All right. Did you figure out this one? Part B.
Oh yeah,
Which region is going to be shaded?
What, the first one?
For the second one, on the Venn
Oh, for
diagram
the
sheet.
second one. Oh wait, never mind. I didn't do the second one. I sent you the shaded region.
Okay, wait, let me see. I didn't receive it yet.
Hmm?
I didn't receive it yet.
It's in the it's in Zoom.
Oh, it's in Zoom. Okay. I thought it was on WhatsApp. Question was F complement intersection S. Okay. So this says F complement and its common part with S. So you have shaded F complement union S. So for F complement, we shade all of this, right? And then um, its intersection with S is just this.
Yeah, that's what I did. Yeah,
I There are
and
two regions in your diagram.
S as well. Yeah, because
You did the universal set and S.
oh no, you know the everything that is shaded, right? Oh, okay, never mind. Okay, yeah, good.
You get it what I'm saying?
Yeah, I got it.
Okay. Okay. Let's go back to this. I think this you can do because this is easy. I think this is also what you can do, right?
Yeah.
Yeah. Okay. Yeah, that's it.
We
So
can
it's
do transformation of Roston.
yeah, we need to look at how we can do how we can do set notation through a shaded Venn diagram. So do you want to cover that first?
Oh yeah.
Wait, I think this is this- let's do the simple ones first and then we can move to the complicated ones. What if this universal set is shaded?
Or A union B not intersect. I mean intersection. I mean like the complement. Yeah. A
So
union B complement.
this?
Yeah.
Yeah, that's correct. Okay. Wait. This, this. Only this region is shaded then. Remember, कोई. Can you hear me?
Yeah, yeah.
So what about this second one? I thought I had lost connection.
Oh, okay.
Yeah, what
This
about
one,
this?
yeah.
Yeah.
Mm. Oh, A intersection B complement, I think. Yeah, yeah,
A intersection B complement.
yeah.
Yeah, that's correct. Okay. Let's do another one. Then we move to the three. Okay, what about this one?
Okay. So I don't know, but I think is it A complement intersection B complement?
A complement intersection B complement. Okay. So when we shared A complement, we shared all of this part. Oops, let me change. When we shared B
No,
complement,
I think it's union. I think it's union. A intersection A complement union B complement, I think.
you think it's A. So you think it's this?
Yeah, yeah.
Yeah, that's correct. Okay. Um, what about this one? This is. mm,
For this one, yeah, I think
Sorry. What do you think it is?
uh I'm thinking.
Okay, sure, sure. Take your time.
Yeah. I don't know how to do this.
Okay. What? I mean, can you tell me your sort of thought process? How were you going about it?
I was thinking that it might be like, a intersection.
Yeah.
I mean, a complement.
A intersection,
No,
B,
a complement.
A complement. Okay.
A complement, then a. I was like thinking intersection B, something like
Okay.
that. I don't know, but I was wrong, I think.
We were thinking A complement intersection B, and that's one bit of it. I don't know what's my one pencil is
Oh, there
there.
are two parts.
Yes.
Oh, okay. Let me try again then.
Yeah.
Because I was thinking about it, but I thought, no, I don't think so.
No, no, you're thinking on the right grounds.
Okay, wait, let me try that. I don't know if it's correct or not, but I think now
Yeah, tell me.
got a first I did is A complement union B complement. So like if we draw it in a Venn diagram, right? Can we like try that? maybe that works.
Okay.
I
So
did the WAG or something else. Yeah,
so
I
you
don't know,
think
was I wrong?
that you can do a
Complement.
wait, just give me. Yes, so you were saying A complement, which means all of this part, union B complement, which means all of this part.
Or it can be this as well, yeah? Because A intersection B complement.
A intersection B, this.
Yeah,
Yeah, so this is this graph, or it was this graph. Both
yeah.
of these
Then
are
how
the
do
same.
you remove the outside stuff now?
Outside stuff.
I mean, like the
You're talking about this diagram?
yeah, I'm talking about that diagram, but like
Yeah.
the only part covered is inside the circle, yeah. Outside the circle is there's nothing. So
Yes.
how do I like remove that on the bottom graph?
Let me tell you. So it's A complement B intersection B. It's gonna be the one. It's going to be one part. So once you put this in a diagram, you get this answer, right?
For what? For what?
For this.
Okay,
Okay, this
yeah.
is part one.
Uh-huh.
Then you do union.
Or do the same thing, but like now B intersection. I mean,
Exactly.
yeah.
So then it's gonna
Okay.
be okay. Do you get it now?
Oh yeah, yeah, I get it now.
Okay. All right. So for the three set diagrams, I need to revise it first before I do it with you. So we're gonna do that in the next class, that is tomorrow, because
Okay.
there are combinations like this and that too. So the diagram that we did in the paper as well, there is a combination like this, but I need to like revise it once before I can teach that to you. So for now, we're gonna shift our discussion to graph transformations, and then we can discuss the three set Venn diagrams in the next class. Okay.
Okay.
So let's talk about yeah. Also, we missed like first 10 minutes, and then I took almost 5 minutes in the middle of the class, so 15 minutes. So 15 minutes of this class we cannot make it up for them today because I have a class immediately after your class. So what we can do is that for tomorrow's class, we can have a 1 hour 15 minutes class. Okay.
Okay.
All right. So there are three types of transformations that we talk about in IGCSEs. So the first one is called a reflection. Another one is called translation. And third one, do you know what the third one is called?
Transformation.
There are three types of transformation. There's
Reflection,
translation
translation, and
and okay. So there is wait reflection, transformation, and there is another one. Why can't I remember its name? Wait, reflection. Okay. So there are these two types, and then there is a type that combines both of these. So that's a combination of reflection.
no, the other one is
And there
It's a
is,
rotation.
yeah, there is another one. There are a couple of other ones as well. There is rotation, and then there is also a combination of reflection, rotation, and rotation, translation. So there are these 6 types that we do in IGCSE levels. Okay. So now let's look at a very basic graph, which is your x square. F of x is equals to x square. So let's say f of x is equals to x square. What does the graph look like for this?
It's gonna be a quadratic, and the minimum point is gonna touch the origin and go out.
Yes. So it's gonna be something like this. Oops. Okay.
Yeah.
Now let's say that I want to translate this graph. I say that f of x plus 1. I do this, which means it's going to be x squared plus 1, right? So whenever this is the case, what you simply do is that the minimum point is at 0. You take the minimum point and you add whatever number is here. So it's 1, so we make the minimum point as 1. If it were 2, then we would have made the minimum point 2. Okay.
But what if it's a sine graph?
Yeah, so that we're gonna move ahead. Like we're gonna do it gradually. So if it is a sine graph, if you so if it's a sine graph, it's going to be like this, right? So
Yeah, yeah.
if it is plus 1, like sine x plus 1, you take this point and you'll push it one step ahead. So this will come here, and then all of the numbers are gonna go 1 point above.
And if we do -1, it goes 1 down, yeah?
Yeah, exactly.
Okay.
Okay. So that's basically translation of the graph. Now,
Yeah.
what if it wasn't, I didn't do this, instead I did this.
Oh, it's gonna move left once.
Exactly. So if it's a positive one, we move it to left. If it's a negative one, then we move it to right.
Right.
So if it were the case of sine graph and it was plus 1, so it would have gone here. And then it would have also stopped 1 behind. Okay. Is this making sense to you?
Yeah, yeah.
Okay. So, and reflection is just simply you reflect the minimum point. So let's take the quadratic graph again. And let's say that it was a transformed quadratic graph, and our graph was sort of starting at this point. -3. It was starting at this point, which is -3 and 2. So when I want to reflect it, what I do is that I trace this point to +3 and I make it a maximum point. Oops. This is reflection. Reflection. Okay.
Yeah, but how do I show this?
What?
Like fx what?
The reflection bit.
Yeah.
Okay, so for reflection, you'll be given points. So you'll have to show the points of reflection or the vector of reflection. So if it were the points, then you would say the points of reflection are 2, 3. If it says the vector of
Oh
reflection,
no, that's not what I'm trying to say.
yeah,
I'm trying to say, like, for translation, right?
yeah,
We did fx like +2. So if it's fx +2, that means it's going up.
yeah.
So like, what do I have to do? Like fx what to like reflect it, Like, if it tells me like fx something,
Mm-hmm.
then how am I supposed to know that this is reflection?
Okay. Yeah, okay, makes sense. All right. So if this was fx, if they give you a negative fx, then you're going to reflect it.
Reflect it to where? X-axis to y-axis.
So see, it depends on what you have here. So if it were x square, fx equals to x square, and now it's negative fx, which means it's negative x square. So it's gonna be this. But of course, it was like this, it would be like this.
Also in the y-axis, yeah?
Yeah. But what if it were
Inside X.
sorry,
What if it was inside X?
inside x, what do you mean by that?
Like F and brackets minus X, No, and
Yeah.
remove the minus Y as well. Like, so F and minus X. Yeah, that's it.
Okay. What
Yeah,
do you think is gonna happen now?
I don't know.
It's not.
So if
So
it's
it's not
if
gonna
it
get.
so if fx was x square, and then if f minus x is what then? X minus square, something like that.
Okay, repeat it again. I'll write it down and then I'll tell you.
For look, for fx, right, it's x square. So when we did minus fx, we got x square minus x square, yeah.
Yeah.
So for f and minus x, what do we do?
So it would just be minus x square. So it would be nothing. There will be no reflection in this. Reflection is just going to happen when you multiply the entire function with negative. And since you're just dealing with f of x and not f of y, so it will only be a reflection in your x-axis.
It's okay. You can't reflect it in y-axis then.
No. So if it is f
Huh?
of x, it will mostly be reflected in x-axis. There are some extreme cases which I can tell you later on, and only in those cases you'll reflect it on y-axis, but majorly it's always going to be in the x-axis.
We so like so it will never reflect in y-axis.
There are some extreme cases where it can, when your equation is a certain way. I'll make a list of it and I'll share with you tomorrow. But in usual cases, when you have f of x and you put a negative behind it, it will always reflect in x-axis. But there are some extreme cases which I'll discuss with you. Okay.
Okay.
But majorly, it is going to be x-axis always. What if it was sine x? F of x equals to sine x, and then I say that negative f of x is equals to negative sine of x. What would happen to the graph of sine now? Actually, this is cos graph. This is sine, sorry.
So mine is negative, yeah. So the top bit goes to bottom and the bottom bit goes up.
Yeah, how do you make it? Can you draw it and send it to me? Are you sending it to me or should I draw it here?
I send it to you. And
Oh, you
zoom.
sent it to me. Wait. Yeah, exactly. This is how it's going to be. And what if there was a translation in it involved as well? What if it was minus sine x minus 1? Then how would it look like?
It's gonna go one down though.
Exactly. So it's gonna be like this. Yeah, I'm gonna go one down. So it's gonna be like this. And I think this is going to touch here. So it's just gonna go one down. I didn't make the graph accurately, but it's gonna go one down. Okay, so we're gonna practice more of these questions tomorrow, and we'll also practice the 3 set Venn diagrams, how we can derive a set notation from a shaded Venn diagram. And I'll also share some extreme cases with you where the reflection is going to be in the y-axis.
Okay.
Okay. Okay. So I'm gonna see you tomorrow, Viraj, and take care.
Bye.
Bye.